Hi and welcome to my very first science video. The topic I've chosen as my first one is the mole and mole calculations, and this is because a lot of my students ask for help with this topic and it can be very tricky. So the mole is going to come up if you are doing GCSE science, so that means combined science or double science. And it will also come up in GCSE chemistry if you are doing triple science, and also in A-level chemistry. So it's important that you understand the very first basic part of moles, and this will be the first part of a series of videos. So 1 mole is the number of molecules or particles or atoms that there are in a substance, and this number is given the number 1.023 times 10 to the 23 particles, and this is called Avogadro's number. I think for A-level you need to memorize Avogadro's number, but for GCSE you will be given this number. And for example, if we take hydrogen, 1 mole of hydrogen will contain 1.023 times 10 to the 23 atoms. It's just a way of describing how many atoms there are. Just like you use 1 dozen means 12. 1 mole means that many atoms. So what we need to do next is to write down the formula for working out moles. So the number of moles is the mass divided by the relative formula mass. Now you're thinking, what is relative formula mass? So this is actually taken from the periodic table, and if you just bear with me, I'm going to change the screen and I'm going to bring up a periodic table onto the screen. As you can see, this is an AQA one, and you can bring up the periodic table of whichever syllabus that you are following. And if you look at this, you've got a key on this particular periodic table, and the key tells you what each box means. So the top number in the box is called the mass number, and the bottom number is called the atomic number. For all of the calculations in this video, we are going to be using the top number, which is the mass number, and it is always the bigger number as well. So we're going to work out the relative formula mass. Let's start with a question. How many moles in 12 grams of magnesium? So we need to look at the periodic table, and if you look at the periodic table with magnesium in it, the symbol for magnesium is Mg, the top number is 24, and this is the relative formula mass of magnesium. Now what we do is we write down the mole formula again. Moles of magnesium equals mass divided by relative formula mass. The mass is 12. The relative formula mass is our number 24, which equals 0.5. No, 12 divided by 24 is 0.5. Okay, let's try another question. This time, if you want to have a go yourself, I would stop the video once I have typed out the question, and then replay it to see if you've done it correctly. So this time we're doing how many moles in 10 grams of helium. So let's write the formula again. Moles of helium equals mass divided by the relative formula mass. What I've done now, just for myself, and you can do this as well, to remind me where I get the relative formula mass from, I've written periodic table in brackets. So moles equals 10. And in helium, I need to look at the periodic table. The top number is 4, so it's 10 divided by 2, which is 2.5 moles. I hope you got that right if you tried it by yourself. Okay, let's try the next question. And I'm just thinking of a question now. Okay. How many moles in 22 grams of water? So this is different to the ones we've done before, because if you try and find water in the periodic table, you will not find it, because water is made up of 2 elements joined together. It's a compound made up of hydrogen and oxygen. So I need to look at 2 boxes. the box for hydrogen, and the box for oxygen. Now the formula for water tells me that there are 2 hydrogens because there are little number 2 after the hydrogen, and there is 1 oxygen. So the top number for hydrogen is 1, and another one, the top number for oxygen is 16. So 2 hydrogens plus 1 oxygen makes 18. Hope you got that right so far. Now we write the formula again. Moles equals mass divided by RFM. And I've written periodic table again to remind me. The mass is given to you in the question, 22. 18 is from the periodic table because we've added everything up. And 22 divided by 18, if I can just quickly do the calculation, comes up to 1.22 moles. And I've rounded it off to 2 decimal places. Okay, next question. We're getting a little bit more complicated now. So this is how many moles in 100 grams of sodium hydroxide. So if you want to stop the video here, if you want to pause it and have a go yourself. For GCSE and A-level, you do need to memorize the formula for sodium hydroxide. I'm giving it to you here. So sodium hydroxide is made of sodium, oxygen, and I'm just writing out the boxes from the periodic table, and hydrogen. And if you remember, it's the top numbers we need. Then we look at how many sodiums there are. In the formula, there is 1 sodium, there is 1 oxygen, and there is 1 hydrogen. So 1 sodium, 1 oxygen, 1 hydrogen. Now the top numbers in each of those boxes, 23 plus 116 plus 1 lot of 1, and that comes up to 40. So this is the relative formula mass, RFM, of sodium hydroxide. I need this to work out the number of moles. Moles equals mass divided by relative formula mass. The mass is given to you in the equation, in the question. Formula mass is 40, and if you work it out, that comes up to 2.5 moles. Incidentally, in an exam, for GCSE exam, this is probably worth about 2 marks. Forgot to put number 4 there, and I'm doing that now. Okay, going to get even a little bit more complicated. So this time, how many moles in 180 grams of, and I'm going to do ammonium, can't spell ammonium, sulfate. You are not expected to know the formula for ammonium sulfate, so I'm going to give that to you here. Okay, it has brackets in it, which is why I've chosen it actually. So ammonium sulfate is NH4 twice SO4. So it's a little bit more complicated. We do as we did before. We need to work out the relative formula mass. So you've got nitrogen, we've got hydrogen, we've got sulfur, and then we've got oxygen. And I'm putting a green dot next to all of the top numbers because those are the numbers that I will need. Now comes the tricky bit. We need to work out how many nitrogens there are. So inside the bracket there is 1 nitrogen and there are 4 hydrogens inside that bracket. But everything inside the bracket has been doubled. So you have to multiply the nitrogens by 2 and the hydrogens by 2. So we have 2 nitrogens and 8 hydrogens. Then if you look at the sulfur, there is 1 sulfur. And then if you look at the oxygens, there are 4 oxygens because there's a little 4 after the oxygens. So now that I have figured out how much of each one I need, I'm just underlining them. So 2 nitrogens plus 8 hydrogens plus 1 sulfur plus 4 oxygens. So nitrogen is 14, so it's 2 times 14 plus 8 times 1 plus 1 times 32 plus 4 times 16. And when you add those all up, 132. So that's my relative formula mass, RFM. Now, as before, we're working out number of moles. We need to write the formula again. Moles equals mass divided by relative formula mass. So the mass is given to you in the question. It's 180, the formula mass we worked out. Divide it by 132 and put the numbers in your calculator, and we get 1.36 moles, rounded to 2 decimal places. Slightly trickier question this was, but very likely, quite likely to come up in an exam anyway. So why don't you have a go at doing these questions yourself, and pause the video and I will post up the answers afterwards. And here are the answers. Let's see if you've got them correct. If you have and you've enjoyed my video, please feel free to leave a comment. Thank you. Bye-bye.